Now we come to the architecture and the functions of Kafka, which is the key point in this chapter. Firstly, the Kafka topology. As we can see from the figure below, there are three roles in this topology: producer, Kafka, and consumer. So quite literally, producers are those that produce all the messages, like the web page or some log services, etc. And consumers are those that require messages for further analysis or persistence, like HDFS, MapReduce, Flink, Hive, etc. And in the middle, we have Kafka, which asynchronously transmits messages from producer to consumers. But please note the following properties. Firstly, Kafka server has a particular name called broker. Namely, broker is the working instance of Kafka. And in a Kafka cluster, there might be more than just one broker. Secondly, the figure tells us that it is producer that pushes data into broker, while it is consumer that pulls data from broker. This means that broker is always passive, because Kafka doesn't know when the data will be produced, as well as when the data is needed. Thirdly, most of the processes and the components are monitored and controlled by Zookeeper, which is exactly the reason why we say Kafka is Zookeeper-based. If there is only one thing Kafka can't operate without, it's Zookeeper. Okay, and this slide shows the basic concepts and their description. Some concepts like broker, producer, and consumer are already introduced before. Next, we are going to introduce topic, partition, and the consumer group in detail. Alright, just as we mentioned, topic could be considered as a combination of one or multiple message queues, and the consumer needs to subscribe to some particular topics for data. On top of that, in each queue, there may be massive messages, and all the messages are ordered perfectly based on their generating time. Here, we can see a figure showing this. In this figure, we can see a topic with only one queue. And in this queue, each blue box corresponds to one message. Producers only append new messages to the end of a queue, which is on the right side of this queue. And the consumer reads data from the oldest to the newest, that is, from left to right. And the position of each message is recorded by the offset. Just now, we have shown a topic with only one queue, but in most cases, there are many queues in each topic, because multiple clients can concurrently access different nodes to read and write messages of a topic, and therefore we can improve the throughput and the concurrency of Kafka. Now, we give each queue a name called partition. Here, we emphasize that each partition physically corresponds to a directory for storage, so they can be read simultaneously. Here, we emphasize that each partition physically corresponds to a directory for storage, so they can be read simultaneously. And in each partition, the messages are perfectly ordered and immutable, and this order is also recorded by the offset. So, what is an offset? Basically, the position information of each message is called offset. And please note that an offset is a long integer. It is not a string or a float number, but a long integer. Besides, it works like a bookmark when consumer is consuming data. When we are reading a heavy book which has thousands of pages, it is impossible to finish it in one go. Therefore, we used to set a bookmark to record the latest page we have read. And this is just the same case as using offset. The offset is like the page number, and each partition has its own independent offsets. Every time a consumer is consuming messages from a partition, it will record the offset, and next time it will start from the latest one in case of duplicated consumption. And also, this offset mechanism guarantees the correct order of messages according to their generating time as well. Okay, so maybe now you can find that the offset mechanism is essential for Kafka, right? And that is why the offset needs to be stored into hard disks for persistence. Here, we can use the following formula for calculation, and this can be done automatically by Kafka. By default, Kafka generates 50 subdirectories for storing offsets under the Kafka logs directory. As for consumer group, quite literally, it is just a group of consumers. And to be more specific, consumer group is an extensible and fault-tolerant consumer mechanism provided by Kafka. And by the way, multiple consumers or consumer instances in the same group share a common group ID. All consumers in a group are coordinated to consume all partitions of the subscribed topic. But please note that each partition can be consumed by only one consumer in the same consumer group. For example, here we have two servers, and each server has exactly two partitions. So totally, we have 4 partitions here, called P0 to P3. In group A, there are 2 consumers, which are C1 and C2. And if C1 consumes P0, then C2 cannot consume P0 anymore. That is why each consumer only consumes 2 partitions. Similarly, in group B, there are 4 consumers, and if C3 consumes P0, then C4, C5, and C6 cannot consume P0 anymore. Therefore, each consumer consumes only 1 partition. This is the meaning of consumer group. Apart from all the basic concepts we introduced before, there are also some important ones like replica, leader and follower, and the controller. For the first 3 concepts, we will introduce them in the next section, and as for controller, just regard it as the supervisor of leader election and failover. Alright, now it is time to have a look at the data management part of Kafka. And in this section, we mainly introduced the replication mechanism, the transmission reliability, and all the data processing methods. Okay, that is all for the second section. Now, in the third section, we are going to introduce the data management modules for Flink.